Hello, today's lesson is 7.5, Writing and Graphing Inequalities. The essential question is, how can you use a number line to represent solutions of an inequality? And here's the four basic inequality symbols. So notice there's less than, greater than, less than or equal to, or greater than or equal to. And I want you to know that the reason that the less than is pointing toward the right is because if you think about a number line, right, if I start with 0, 1, and 2, numbers get smaller in this direction, right? So that's the less than symbol. And numbers get bigger in this direction, which is why the greater than symbol points toward the bigger numbers. And then there's this other, like it's half of an equal sign. And we'll talk more about what the less than or equal to and the greater than or equal to mean. So there's an activity in your record and practice journal that you should go ahead and do. It's on page 167. So get your record and practice journal. And basically what you're going to be doing is you're going to be circling each number that makes the statement true, right? And then you're going to answer the question. So notice the first one says, your friend is more than 3 minutes late. And so if your friend is going to be more than 3 minutes late, they can't be exactly 3 minutes late. So you would circle the 4, the 5, and the 6. And then the questions are, what did you notice about the numbers you circled? Is the number 3 included? And then write 4 other numbers that make the statement true. So go ahead and pause this video and go ahead and try to answer those questions. And I'll show you that hopefully you're noticing that all of the numbers are bigger than 3, right? And then the second one, no, the number 3 is not included because this seems silly. 3 is not more than 3. And then write 4 other numbers that make the statement true. So I don't have to pick 7, 8, 9, right? I can pick any number that's bigger than 3. So I could pick 25. I could pick 35. I could pick 100 minutes later, or I could even do 1,000. All of those numbers are greater than 3. Okay, so there's some more examples like this. This one says the temperature is at most 2 degrees. So here's what you should be thinking about. When you see this language at most, that means it can't be any more than, right? So if it's at most 2 degrees, I would be circling, like definitely can circle the 2 because at most includes that. So I could circle the 2, and then I'm going backwards and I'm circling all of the numbers that are less than 2, because at most is kind of like a maximum, right? So it's like a maximum limit. So that's why I couldn't circle 3 and 4. And then go ahead and pause the videos and see if you can answer the other questions. So what did you notice about the numbers you circled? Hopefully you noticed that the numbers are 2 and less than 2. And then, can it be exactly 2? Yes, it can, because 2 is a maximum temperature. And then we could do things like minus 20, right? Minus 40. Maybe I could do minus 100. Maybe I could do minus 500. All of those numbers are less than 2. Of course, this would be an unreal temperature. Okay, so this is number C, letter C. You need at least 4 pieces of paper for your math homework. And so I want you to think about this. When you see at least 4, that means that is a minimum, right? So I want to think about that as a minimum amount of paper. So if I need at least 4, that means I could get 5 or 6 pages, but the smallest number that works is 4. And then pause the video and answer the questions. What do you notice about the numbers that you circled? They are 4 and greater than 4. Can you have exactly 4 pieces? Yes, because 4 is the minimum number that you need. And then you can write 4 other numbers, right? If I don't want to be creative, I can just do 7, 8, 9, and 10. Don't want to use too much paper for our math homework. Okay, I think this is the last one. Yep. Okay, so after playing a video game for 20 minutes, you have fewer than 6 points. So, fewer than 6. Well, if it's fewer than 6, that's less than 6. So I can't circle 6. So I'm going to circle this. And maybe negative points don't necessarily make sense, but all of these numbers would make the statement true. And then pause the video and answer the other 3 questions. So here we go. You should notice that all of the numbers are less than 6. You should notice that the number 6 is not included because that makes no sense. 6 is not less than 6. And then 4 other numbers that make it true. I could do -4, -10, -15, and maybe -25. Okay, so now I want you to think about what's the difference between an equation and an inequality, right? And you should remember that an equation, right, has an equal sign. An equation, another equation that has an equal sign. And then inequalities, they have these inequality symbols, right? So equations have equal sign. Inequalities have the inequality symbols. But they're both telling you, so this tells you that an equation, right? Remember that the 2 sides are equivalent. And then an inequality compares the 2 sides in some way. So, sorry, so the difference is the equation has an equal sign and inequality has the inequality symbols. And then in an equation, the 2 sides are equivalent. And in an inequality, you're comparing the 2 sides. And that means that usually one is bigger than the other. Okay, so this is in your textbook. And here are the symbols and the words that go with these symbols. So here's the less than, greater than. This symbol, and this is how we read it, right? Is less than, is greater than. And then this symbol means is less than or equal to. So the first phrase with the dot is exactly how we say it. And then underneath it, it's kind of the phrases that mean the same thing, kind of like synonyms, right? And then what I want you to think about is the words minimum and maximum, right? So remember that at least, this is a minimum. So I'm going to add the word minimum here. And then no more than is a maximum. So I went to a zip line once and they had a minimum weight you had to weigh greater than, I think it was 100 pounds. And then the maximum, the weight you had to be less than 250 pounds. So I always try to think about that zip line to remember the minimum and maximum. And if you think about it, it made sense because if you didn't weigh a minimum of 100 pounds or some certain weight, there's a potential that you could get stuck in the middle of the zip line, right? And then, you know, how are you going to get, well, you wouldn't be standing on the zip line, but if you don't weigh enough, your weight can't carry you down to the bottom of the zip line and you would get stuck in the middle. Now, the maximum weight is for safety reasons as well, because if you weighed over a certain amount of weight, the cables, right, maybe couldn't hold that weight. So it's potential that the cables could break. And so for safety reasons, there is a minimum weight and a maximum. So I want you to think about those words that go with at least and this that goes with at most. Okay. So here's a review of the symbols. Now, I guess we should probably include, right, this is technically an inequality because you're saying that the 2 sides are not equal. And there's our symbols. Now, this one's kind of a little wonky sideways. Usually the less than, the half of the equal sign just goes a straight horizontal. It's usually not angled like that. And then remember, the crocodile does eat the bigger thing, but it's sort of like this. When I write it this way, 4 is greater than 3. And when I write it this way, 3 is less than 4. Now, the crocodile is still open to the bigger side, but each of those phrases is said differently, right? This is 4 is greater than 3, and this would be said 3 is less than 4. Okay, so now we're going to write some inequalities, and these are in your textbook. And so I translate the inequalities the same way I do equations. And so I usually circle the important numbers. So I'm circling the C, and I'm circling the minus 4. And then I'm going to underline is less than, and I'm going to use my chart. And I know the is less than symbol points to the left because that's where the smaller numbers are. So I literally translate it, C is less than -4. And then for B, I'm going to circle a number K. There's a +5, and there's an 8. And I'm going to underline, plus means addition. I'm going to underline greater than or equal to, and that's my greater than or equal to symbol. And with all my notes up here, it makes it really easy to translate the word into the inequality. K plus 5 is greater than or equal to 8. And the last one, I'm going to circle 4, a number Q, and 16. And I'm going to underline times and is at most. Ooh, is at most. Okay, that sounds like that maximum. So I might want to go back to my chart and remember if I have a maximum, it's going to be this symbol is less than or equal to, because your number can't go over that. So I'm going to put in the less than or equal to. Okay, and then for times, I'm going to use a dot because I don't want to use an X. It looks like a variable. 4 times the number Q. So 4 dot Q, well, wait a minute. Can't I just get rid of the dot and write 4Q? It's probably a better way to go. So 4Q is at most, is less than or equal to 16. All right, these are the OYOs. So go ahead and pause the video and try these 4 on your own. So I'm going to circle it, number N. I'm going to circle the 1 is greater than, just looks like that. So N is greater than 1. Twice. Ooh, that means I'm multiplying it by 2, right? So, that means I need to underline that. That's my math word. I'm underlining that, and that means 2 times. So I've got a number P, I've got a number 7, fewer than. Oh, that's the same thing as less than. Now remember, is fewer than, okay, so this is what's tricky. Is fewer than is the less than symbol. If I get rid of the is and just write fewer than, that's subtraction, right? So this is an operation, and this is a comparison. So be very careful and pay attention to if there's an is or not. Is fewer than is the comparison, and just if I have just something that says fewer than, that means I'm subtracting. Okay, so twice the number P. That means it's 2 times P is fewer than, that's my is less than 7, right? So it's not 2P minus 7 because of the is. It's a comparison. A number W, I'll circle the number W, I'll circle the 3, and then the 10. I'm going to underline the minus, it's a subtraction, is less than or equal to. I'm going to underline that and write the is less than or equal to symbol. So this becomes W minus 3 is less than or equal to 10. And the last one is Z. There's a 2 and a -6. I'm going to underline the divided by and write the division symbol. Is at least. Okay, I think that's a minimum, right? So I can go back to my list. Is at least. Yep, that's a minimum. So that's the symbol I'm going to use. Is at least. That means it can be that number. Okay, so I've got Z divided by 2. So let's make it fancy and use the fraction bar. Z divided by 2 is at least -6. So it's greater than or equal to -6. Okay, so now the other thing you need to know is how to graph an inequality. So the graph of an inequality shows all of the solutions of the inequality on a number line. So see this inequality right here, x is less than 1. I put an open circle around the 1, and then I draw the arrow to the left. It matches the direction of the inequality. All of these numbers are less than 1. Now remember, it includes all of the numbers in between, like 0.5, right? It includes all of the decimals and fractions, because all of those numbers are less than 1. In fact, I mean, right, I can think about what number goes here. What is so close to 1 but not really there, right? Like this, 0.999, right? How many 9s can I make to show you that I'm getting really close to 1 but not equal to it? That's what I want you to think about. So a less than symbol doesn't include the number, so the circle is open. The greater than symbol right here also doesn't include the number, so the circle is open. So this has an open circle at 1, and it's all of the numbers to the left. Notice for x is greater than 2, I do an open circle at 2, and it goes to the right because I'm choosing all of the numbers that are greater than 2. So all of these numbers make that true. And then we have the the less than or equal to symbol. And for that one, you just have to remember that we do a closed circle. And the closed circle means it includes -3 and then all of the numbers that are smaller than -3. And same thing with a greater than or equal to. It's a closed circle, and if you're graphing all of the solutions, all of the things that make this true, it's all of the numbers greater than or equal to -4. So I put a closed circle, it includes -4, and then I make my arrow go to the right. So the open circle is not a solution, but a closed circle is a solution. And then everything else under the arrow, under the line that you've shaded in, is a solution. Okay, so this is the first time you're graphing an inequality. And so I like this little tip here that is letting you know that 2 is less than g is the same as g is greater than 2. But I'm going to show you what happens and why it's a little bit tricky if you do this. Okay, so I want to graph all of the numbers that are greater than 2. So because it can't be equal to 2, I'm going to do an open circle at 2. And then I'm going to shade in my line right here, and I'm going to make this, right, an arrow that goes to the right. In fact, I think I just want to do a highlighter. Okay. So you have a pencil. You can go just a little bit above the line to make it dark enough. All right, so there's my solutions. Now here's what's tricky. I want to show you that if I say 2 is less than g, well, that means g is bigger than 2, right? So I just want you to know if the variable is not first, the arrow goes in the opposite direction. Notice in this one, the arrow is going to the right, or the inequality points to the right, and the arrow points to the right. But if you switch the direction of the inequality and you put the variable second, then right now the inequality points to the left, but the solution, all of the numbers that are bigger, are off to the right. So it's not a bad idea to think about rewriting the inequality. So if I gave you this to graph, you could switch everything around as long as the crocodile was still eating the g, right? Because the g is bigger than the 2. Okay, so here we go. You're going to try graphing these. Now there's no numbers on these, so I'm going to give you just a little bit of instruction on making a number line. Remember, we want our numbers to be evenly spaced. And notice this is going to include a 4. So usually what I do is I will find a good place for a 0. So I'm going to pick 0 here because I need to graph the circle at 4. So I do 0, 1, 2, 3, 4. And now I'm going to do an open circle at 4. So here's my open circle. And then the inequality points to the left. I'm picking all of the numbers that are less than 4. So I'm going to go ahead and just grab a blue highlighter, and this is my graph. All of the numbers that are less than 4 will make that inequality true. Okay, so pause this and try the rest on your own. Oh, sorry. What I should tell you is you don't always have to put 0, but because these numbers are kind of small, you can put a 0. What a lot of times I will do is I'll pick this number 7 and I'll add a number line that has 6, a 7, and an 8. So I usually pick one number on each side to include in my number line, and that's all I do. So for instance, I might do a number line that just has 6, and I'll skip the space, put a 7, I'll skip the space, and put an 8. So as long as you have at least, here's my tip, I want you to have at least 3 numbers on your number line. And usually it makes sense to pick the number to the left of the target number and a number to the right. So there's my 6, 7, and 8. And pause the video and try to graph the solutions of the inequality. Okay, so this one includes a closed circle because all of the solutions F are less than or equal to 7. So it can equal 7. So I'm going to go ahead and do a closed circle. And then I'm going to highlight all of the numbers that are less than 7. And the next one is n is greater than 0. So let's just go ahead and put a 0 here. And then 1 would be here, and -1, even though we haven't covered integers yet. I want you to know that the negative number line looks just like the positive number line. It just goes in the other direction, right? So a positive 2 would be here, and a negative 2 would be here. So you start counting to the left from the 0, the same way you would for positive numbers. Okay, so the solution of n is greater than 0. It's going to be an open circle because it doesn't include 0. So I do an open circle, and then I'm highlighting. My arrow goes to the right, all of the numbers that are greater. And the last one is p is greater than or equal to -3. So I might just put -3 here on my number line and put -2 over here. Oops, wait a minute, that's not right. It has to count from the 0, right? So this should be -4, and over here would be -2. Okay, so I'm trying to graph all of the numbers that are greater than or equal to -3. So I'm going to put a closed circle on the -3 because it includes that number. And then I'm going to highlight, and my arrow is going to go, oh, that's fine. My arrow is going to go off to the left. All of the numbers that are greater than -3 will be on the left-hand side. All right, so the last thing I want to talk to you about is just that a solution of an inequality is a value that makes the inequality true, right? So there's such a thing as a solution set. So I want you to think about this. It's kind of like solving equations. If I think about what value of x could make this inequality true. So I'm pretty sure you can figure out that if this was an equal sign, right? X plus 3 equals 7. You would be thinking that it's possible that x equals 4, right? So right now I've got 4 plus 3 is greater than or equal to 7. Is that true? And you would say yes. Now let's pick another number that's going to make it true, like x equals 0, right? So what if I plug in 0? So I get 0 plus 3 is less than 7. And you would say, yes, that is also true. But now what if I pick something like 5? Okay, so now I'm going to pick x equals 5. And when I plug that in, 5 plus 3 is less than or equal to 7. What? You're going to say, no, that's not true. And now I'm going to make a quick number line and show you why that totally makes sense. So let me make a little number line here. Oops, let's go back. I want to just do, okay, here's a nice little number line. Okay, so now let's put, this is where we were pretending it was equal. So let's put 4 here. Let's put 3, 2, 1, and this would be 0, and this was 5. So if I think about graphing the things that made it true, okay, so 4 made this inequality true. So I'm going to put a closed circle on 4. And then if I think about, if I plug in 3 plus 3, that's 6, that's less than 7. Okay, that one made it true. And then 2 plus 3 is 5, definitely less than 7. 1 plus 3 is 4, yep. Okay, so all of these numbers, right, are making the inequality true. So you might see that what it looks like is I should probably just draw an arrow, right, going off to the left, and 4 is the last whole number, right, that makes this true. And when I get to 5, notice that 5 is not underneath the arrow or the highlighted part that makes the solution, that is part of the solution set. So it turns out that there's a whole bunch of numbers that make the inequality true, but you can also come up with numbers that don't make the inequality true. And in that case, they shouldn't be underneath the arrow. So if somebody accidentally graphed the solution set and it went like this in this direction, you could check it and you could pick 5 or 6 and plug that in and see if it makes the equation true. So this won't be in your homework, but the last thing I wanted to show you is that a lot of times the solution set is shown with this little brackets, right? So I could say that the solution set, let's see, 4 made it true, 3, 2, 1. Well, we know there's a whole lot of numbers, but a lot of times the solution set is put into these fancy brackets. Okay, and it turns out that later you will be solving inequalities the way you solve an equation. I just want to give you a preview of this. I can just pretend this is an equal sign with a balanced. It's not really balanced because there's no equal sign, but this side is less than this side. So let's kind of use the strategy that we use to solve equations and take 3 away from both sides. It looks like my new inequality is all the numbers that are less than or equal to 4 are part of this solution set. So I might actually put a little bracket around this and say that any number that's less than or equal to 4 makes this inequality true. Okay, that's it for the lesson.